Graphs of polynomial functions. Let p of x represent a polynomial function. The zeros and the sign of p of x around the zeros may be determined using a table of signs, provided p of x is expressed in fully factored form. So for example, sketch the graph of p of x equals x plus 3 all cubed multiplied by x plus 1 all squared multiplied by x minus 2. The zeros are found by solving each linear factor equals 0. So our first linear factor is x plus 3. So x plus 3 equals 0, and the solution to that is x equals negative 3. Our next linear factor is x plus 1 equals 0, and the solution to that is x equals negative 1. And our third linear factor is x minus 2 equals 0, and the solution to that is x equals 2. So these are our three zeros, negative 3, negative 1, and 2. Next, we draw up a table of signs with the zeros and values close by to those zeros. So the zeros are written in green, and I've chosen some convenient values around those zeros. Now the value of p of x, if it's positive, I've written it in red, and the value of p of x, if it's negative, I've written it in blue. And from this table of signs, I can deduce, or at least estimate, the shape of this curve. Now something to note here is that the shape of the graph close to x equals negative 3 looks like a cubic. And if you look at the polynomial p of x equals x plus 3 all cubed, so the 0x equals negative 3 belongs to this linear factor, and you can see that this linear factor is raised to the power of 3. So therefore, it would have, or would resemble, a cubic shape around that 0. The shape of the graph close to x equals negative 1 looks like a parabola. If you look at the polynomial in fully factored form, the 0 x equals negative 1 belongs to this factor here, x plus 1 to the power of 2. That's quadratic, so that would form a parabola, or the shape of a parabola around that 0. And lastly, x minus 2, that's raised to the power of 1. The shape of the graph close to x equals 2 looks linear for that reason, because the power of x minus 2 is 1.